Well, good morning, all of you. Continuing with whatever we had started. We had started with parallelogram proofs. We will see special parallelograms today. There are three different special parallelograms that we will be working on today. The first one is the rhombus. Then we will see a rectangle and square. So we will see first is the rhombus, then we will see a rectangle. Okay, what is a rhombus? Rhombus is an equilateral parallelogram, which means equilateral means all the sides are equal. It's an equilateral parallelogram, which means all the four sides of the rhombuses are, if you have a rhombus, then all of its sides are equal. So it's something like this, where you have all these sides are equal. Okay, basically it means it's a parallelogram where all the four sides are equal. In case of a rectangle, it's an equiangular parallelogram. It's just equiangular. It's not equilateral. It's just a equiangular. What does equiangular means? Not all the sides are equal. Only the For it to be equiangular, only the opposite sides are equal, but whereas all of its angles are equal. These angles are equal and they are 90 degrees. If they have to be equal, then they have to be 90 degrees. A rectangle is an equiangular parallelogram where all four angles are congruent. Okay. And what is the measure of each angle? As all the angles. So for rectangle, you know the sum of angles. Sum is what? How did I get a 90 here? I'll tell you. Sum equals n minus 2 times of 180. That's what we had seen in the previous class. And here is n is the number of sides. We have 1, 2, 3, 4 sides. So 4 minus 2 times 180. So sum of all the four angles is 360 degrees. And we want to have all the angles to be equal, which means I can tell each of these angles, let me call it as x units. So I can say 4x equals 360. Then dividing by 4, I get x equals 90 degrees. Okay. But our actual definition of rectangle is, it is an equiangular parallelogram. The actual definition of rhombus is, it's an equilateral parallelogram. What's a square? A square is a regular parallelogram, which means all of its four sides and four angles are equal. A square is both rhombus and a rectangle. I'll just draw the square in different color. It's an equilateral and equiangular. All of the four sides are equal, which means this particular, all the four sides are equal and all the four angles are equal. Here also all the angles will measure 90 degrees. Okay, I'll give you like a 30 seconds here. I want you all to note down, then we can move ahead to the next slide. Okay, let's continue from where we have left. Let's go to the next slide. Okay, I want you all to use your chat and tell me which of these statements is true and which of these statements is false. You don't have to write complete true, false, all that. You can just tell, for example, you can tell if a quadrilateral is a rectangle, then it's a parallelogram. I know it is true, so I'll just tell in my chat, if I am your place, I'll tell 1 T. Okay, same I want you to tell what is second one, third one, fourth one and fifth one via chat. So use your chat and tell me whether they're true or false. I want maximum participation here, so I'll give you exactly like a minute or so. Okay. We know that if a quadrilateral is a rectangle, then it's a parallelogram. That's true. That's the definition of a rectangle. Rectangle is what? Rectangle is a equiangular parallelogram. So therefore it has to be true. If a quadrilateral is a parallelogram, then it is a rhombus. Need not be. Okay, it can be just a parallelogram, it can be rectangle, it can be it can square is a rhombus. So it can be a normal parallelogram or it can be a rectangle. So this has to be false. Second is false. The first one was true, which we already had discussed, so I'm not detailing that. If a quadrilateral is a square, then it's a rhombus. A quadrilateral is a square when it's a equiangular and equilateral parallelogram. But what is a rhombus? Rhombus is nothing but a equilateral parallelogram. So square satisfies the definition of equilateral parallelogram as well. So therefore this is true. Let's see the next. If a quadrilateral is a rectangle, then it is a rhombus. Definition of a rectangle is what? It is a equiangular parallelogram, and this is equilateral parallelogram. Both are different, so this has to be false. If a rhombus is a square, then it's a rectangle. A definition of square is what? Uh, Parallelogram, which is equilateral and equiangular. Rectangle definition is a parallelogram which is equiangular. Square satisfies the definition of rectangle, so therefore I can say it's true. Okay, let's move on to the next slide. Properties of special parallelograms. In addition to the properties of parallelogram, to all the properties of parallelogram, we had discussed what are the properties of parallelogram in the previous class. The opposite sides are congruent, the opposite angles are congruent, adjacent angles are supplementary, and we had said that the diagonals bisect each other. Okay, in case of parallelogram, I'll just draw and discuss once again whatever we had. So we had said the opposite sides are equal or congruent. That is our first property in case of a parallelogram. Then we had said the opposite angles are congruent. Means these two angles are congruent. The one with two arcs and one with one arc, these two are congruent. And we had also said that the diagonals bisect each other. Third property that we had seen was the diagonals bisect. I think the stylus is giving little, it's not behaving the way I want, so I may have, so diagonals bisect each other, which means this is equal to this, that this is equal to this particular. We are not saying all the four are congruent. But apart from those properties of parallelogram, there are some more properties which we have to keep in mind. The first one is the diagonals of rhombus bisect the opposite angle of the rhombus and are perpendicular to each other. Okay, this is a special property of the rhombus. What does this mean? Is supposing I have a rhombus. The diagonals will bisect the opposite angle. So in the first part it says if I have a diagonal, it will bisect the opposite angle, which means these two angles will be congruent. Same with these two angles will be congruent. And they are also saying in this property that see if I have another stylus, give me a sec. Okay, what does this property say is if I have a rhombus, then it will bisect these angles. It will make this particular angles congruent. That's what The diagonals will bisect such that the angles become congruent, and same way these angles will be congruent as well. They are different angles, okay? They are, it, rhombus is not a equiangular, it's a equilateral. Same way here also they bisect. So these two angles will be congruent. These two angles are 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 congruent. The diagonals of rhombus bisect the opposite angles of the rhombus and are perpendicular to each other, which means I will have a 90-degree here. The diagonals are perpendicular, so this is 90 degree, this is also 90 degree, this is 90 degree, and this is 90 degree. They are perpendicular to each other. That's what this property says. The next property is that the diagonals of a rectangle are congruent. In case of a rectangle, the complete diagonal itself will be congruent. For example, if this is my A, B, C, D, it says that AC is congruent to PD. Okay, that's what this particular property says. We had diagonals bisect each other in case of any of these, because all of these are parallelograms. But special property of rectangle is that the diagonals are congruent. Then next, if both diagonals of a parallelogram bisect a pair of opposite angles, then the parallelogram is rhombus. If both the diagonals of a parallelogram bisect a pair of opposite angles, then the parallelogram is a rhombus. Okay. If this property is satisfied, if that's telling it in a reverse manner, like how we had here, the diagonals of rhombus bisect the opposite angles. Supposing we have a parallelogram and we see that this happening. If we have a parallelogram and we see that the opposite angles of the rhombus are being bisected, then we can straight away say that it's a parallelogram. Straight away we can say that parallelogram is a rhombus. Same way we can say that if the diagonals of parallelograms are perpendicular, that time also we can say that the parallelogram is a rhombus. Okay, keep this in mind. If either the angles are being bisected in a parallelogram by the diagonals, then we can say it as a rhombus, or even if the diagonals are perpendicular in case of the parallelogram, then we can say it's a rhombus. And same with the opposite of this, whatever we had. If the diagonals of parallelogram are congruent, then we can say that parallelogram is a rectangle. Okay, these are the three extra properties with the other three properties which we saw, which satisfies for all the three parallelograms. But these are specific to rhombus and rectangle, these properties. Okay, I hope this is clear. We will see few problems based on them in the next slide. In the diagram shown, BDEG is a rectangle and ABCD is a rhombus. Okay, BDEG is a rectangle and ABCD is a rhombus. Find the measure of the indicated angle. They are asking us to find angle GDB. They are asking us to find this particular angle GDB. Okay, so first of all, they have said BDEG is a rectangle, and they have said ABCD is the rhombus. Okay, based on the property of the rectangle, so first of all I know that if it's a rectangle, let's only take care of the rectangle BDEG first. If it's a rectangle, I know that it's a equiangular. If it is equiangular, then this particular angle which I have, HDC, This angle is going to be 90 minus 63 because all the angles are equiangular. So 90 minus 63 gives me 27 degrees. And in case of a rhombus, I know ABCD is a rhombus. In case of rhombus, the diagonals bisect each other. So if this is 27, then this is also 27. Because in case of rhombus, the diagonals bisect the angle. So first one I can say that they were asking what? G G D B, which is 27 degrees. Then next they are asking angle ABC. I know these are 27 and 27. In case of parallelogram, the opposite angles are congruent. So 27 plus 27 is nothing but 54. So this particular angle, whole angle ADC is 54. ABC is the opposite angle of a parallelogram. So this whole angle is 54 degrees. This whole angle. So I can say that angle ABC is 54 degrees. Then next, let's see what they are asking. Angle DAB. Let's see, where is DAB? Okay, they want us to get this particular angle DAB. We had the property which says that the adjacent angles in a parallelogram will add to 180. Adjacent angle will add to 180. So we had angle ABC is 54, which is adjacent to angle DAB. So 180 minus 54 will give us 126. So this angle is 126 because adjacent consecutive angles will add to 180 degrees. The adjacent consecutive angle, angle A plus angle B should be 180. This is 54 we know. So 180 minus 54 will give us 126. So I can say this one, angle DAB as 126 degrees. Next, let's see what they are asking. Angle BCG. They are asking us angle BCG. Let's get to that in a while. So first of all, let's try to get all these angles. If this is 126, the opposite angle also is 126. So this angle, this whole angle is 126. Okay, this BCG, I know that angle BCG plus angle BCD is 180 degrees. They are in a straight line, right? This should be 180 degrees because the adjacent angles which lie in a straight line. But already I know that BCD is 126 degrees. So BCG is going to be 180 minus 126. So if I do 180 minus 126, I'll get 54 degrees. So this angle BCG is 54 degrees. Next, let's see what is being asked. Angle GCE. So opposite vertical angles are congruent, right? So BCD is 126, so GCE is also 126. So this angle is also 126. This whole angle, okay? Not just only this portion. This whole portion is 126. So I can say that GCE is also 126. Next, let's see what are they asking. Angle DEG. DEG is quite simple. because rectangle, all the angles are equiangular and they should be 90 degrees, so I can say this as 90 degrees. The last two, angle AHB. Angle AHB. In case of a rhombus, we learned that diagonals bisect the opposite angle and diagonals are perpendicular to each other. So angle AHB is 90 degrees. And the last one, DGB. So DGB, you can see that this is like your parallel lines. So observe, BD is parallel to GE because all the rectangles are parallelograms, so the opposite sides will be parallel. And this is like your transversal, the line GD. Okay. Alternate interior angles will be equal. If this is 27, then this is 27. So angle DGB will be equal to 63. So same way this is going to be 63. Okay. So this particular side will be equal to this particular side and they will also be parallel. And this time this will act as a transversal and this itself can be taken as transversal, and this is 63 degrees. Okay, that's how we written 60. Let's move on to next slide. Classify the special quadrilateral, explain your reasoning. Okay, you have to classify these special quadrilateral and explain your reasoning. Okay, first one I will do, then the second one I would like you to try. And they are asking us to find x and y also. For the first one, it's an equilateral parallelogram. It's not an equiangular, equilateral parallelogram, so it's a rhombus. And opposite angles will add to 180, so I can say 108 plus 7y minus 5 equals 180 degrees. It's not writing in the place that I intend to write, but I'll simplify this further and I can add 108 minus 5, which gives 103, and subtract 103 from both sides to get 7y equals 77. So the next step I can just and dividing by 7 on both sides, I'll get y equals 11. So for this problem I can just simplify and get y equals 11. On the next one, 8x minus 3 equals 4x plus 17. Both the sides are equal. That's what we saw in case of the rhombus. We should have these two equal. So 4x plus 17 is equal to 8x minus 3. So subtract 4x from both sides and add 3 on both sides. So I'll get, once I subtract 4x from both sides and adding 3, I get 20 equals 4x. And then dividing by 4, I get x equals 5. Okay. I want you all to try this problem same way. Okay, I'll give you like a minute or so, classify this particular parallelogram and also find the values of x and y. Okay, let's continue with this particular problem. First of all, they have given us it's a equilateral and equiangular, so this is a square. We can easily conclude that it's a square. Then next, we can say that 5y plus 16 is 10y minus 9 because the sides are equal. 10y minus 29. So subtract 5y and add 29. So that gives us 16 plus 29 is nothing but 45. And 10y minus 5y is 5y itself. And dividing by 5 on both sides, I get y equals 9. Okay, if I divide by 5 on both sides, I get y equals 9. And next we want to get the angle. Okay. So they are asking us only this particular portion. They have given this as 6x plus 21, this angle, and they are asking us to find the value of x. This we know that is 90 degrees. Okay. Here they are indicating this particular angle only, right? Or are they indicating the complete one? Okay, let's make it a little more clear. They are indicating only this portion as 6x plus 29. So first of all, this whole angle is 90 degrees and this bisect, this is a rhombus also. So these two also will be equal. So I can say that 45 equals 6x plus 21 instead of 90. That part is not clear, but in case if I ask question, I will make it clear telling that here the angle value which indicates is for the angle RP. Q is 6x plus 21. So if I have angle RPQ is 6x plus 21, I can say that 45 degrees equals 6x plus 21. Subtracting 21 from both sides, I get 45 minus 21 is nothing but 24 equals 6x. And dividing by 4 on both sides, 6 on both sides, I'll get x equals 4. Okay, I hope this is clear. Let's see the next slide. The diagonals of rhombus RSTV intersects at U given that measure of angle URS. Okay, measure of angle URS is this is U, this should be U, okay, because it's a RSTV intersect at this is T and this is B. Given that measure of angle URS is 71 degrees and RV is 44, then indicate the measure of following. Okay, try all of this. You can just label 1, 2, 3 and 4. Okay, I'll discuss answer in exactly a minute or so. Okay, let's see this part. So we have measure of angle URV is supposed to be found. In case of a rhombus, these two bisects, so which means this angle is congruent to this particular angle. Okay, if angle URS is 71, then URV or VRU is also 71 degrees. RVT is the adjacent angle to basically this whole V. V is adjacent to this R. R is 71 plus 71, which is 142. And this is adjacent, so adjacent angles add up to 180, so you can do 180 minus 142, which is sum of 71 plus 71, which gives us RBT as 38 degrees. Okay, next let's try the harder ones. RT. To find RT, Let's observe this particular. Observe only the right triangle RUV. Observe the right triangle RUV. So observe this right triangle. And because it's a rhombus, the diagonals will the diagonals will bisect in a manner such that I get a 90 degrees. Okay. Stylus is still not up to mark, but observe this particular triangle, which I say is, observe the triangle RUT, and this is going to be 90 degrees. If this is 90 degrees, we can apply our trig rules. So with respect to 71 degrees, this is my hypotenuse and this RU is adjacent. When adjacent and hypotenuse are involved, I can say that cos of 71 degrees, I am applying to triangle RUT, is nothing but RU over RV. So substitute here what we have. RU I don't have, but I have RV as 44. RU over 44. Okay, then I can multiply 44 on both sides. And get the value of RU. So RU equals 44 times cos 71. If I substitute that in calculator, it gives me 14.325. 14.325. Okay, it's a simplification of 44 times cos 71. I did this simplification to get RU. Then I need RT. We know that in parallelogram the diagonals bisect each other. So RU equals UT. So RT equals twice RU. So RT equals twice of RU. So multiply by 2, you get 28.650. I'll just write one more step in case RT equals twice RU. So I just did this and I got RT equals 28.650. So I'll put here 28.65 or 650. Now to find SU, same way SU. Let's now observe this particular triangle RSU. Here once again I have a right angle here. This and it's a rhombus, so all the sides are equal. So this is 44, and I'm interested in this one. So this is the, with reference to this particular angle R, this is your opposite and this is your hypotenuse. If the opposite and hypotenuse are involved, we will use sine. So sine of 71 equals opposite, which I don't know, which is US or SU. Just keep it SU itself. SU over hypotenuse, which is RS. Sine 71 equals SU over 44. Simplifying further, multiplying by 44 on both sides, I get SU equals 44 times sine 71. 44 times sine 71, which gives us 41.603. This is our SU. Okay. Now all of you try this one. The diagonals of rectangle WXYZ intersect at O given that XYW XYW is 56 and WY is 33. Find the indicated measure. Okay, you have like a minute and a half and then we will go over solution. To find XWO, this is the alternate interior angle for this particular portion. Because it's a rectangle, so it's a parallelogram. So these two will act like the parallel sides and WY will be transversal. So I need to find this angle. This angle is 90 minus 56. So 90 minus 56 will give me 34. This portion is 34 degrees. So this also is 34 because alternate interior angles are congruent. Then next, ZOY. So they are asking us ZOY. I have this as 34. Okay, and I need to find this particular angle first. We can get this particular angle. It's going to be here. If this angle is going to be congruent to this particular angle, which is in case of rectangle, all these are congruent. So it will act like an isosceles triangle. If this is 34, this also becomes 34 degrees. You don't have to do extra, you don't have to put extra effort. In case of a rectangle, all the portions of these diagonals will be congruent. That is, WO is congruent to OX, OX is congruent to OY, OY is congruent to OZ. So these two congruent sides will make this particular triangle ZOY as isosceles. So I have this particular angle as 34. To find ZOY, I can use sum of angles in triangle as 180 and I can subtract these two. 180 minus 34 twice. I have to subtract 34 twice to get 112 as the required angle. So 112 is our ZOY. Next they are asking us XO. But we have the value of WY. If WY is 33, each of this is 33 divided by 2, which is nothing but 16.5. So this is 16.5, this is 16.5, this is also 16.5, and this is 16.5. This will apply only to rectangle. If it was a other parallelogram, only this portion is congruent to this portion is congruent to this portion. But in case of rectangle, all these four will be congruent. So therefore, XO is 16.5. Let's try the last one, WZ. To find WZ, let's use this particular triangle WYZ. Observe triangle WYZ. So observe this particular triangle WYZ. This is a right angle. Okay, this is a right angle, and you have WY as 33, and you are interested in this. And you know this is 34 degrees. With reference to 34 degrees, I am just taking this angle as a reference. With reference to 34 degrees, this is my opposite and this is hypotenuse. So I can say sine 34 degrees equals, opposite is nothing but, I'll just write opposite, which is WZ, over hypotenuse, which is WY. And then we will substitute whatever we have. We have WY, which is 16.5 plus 16.5, which is 33. And further simplify this, multiply by 33 on both sides. So 33 times sine 34 gives us WZ as 18.453. 18.453. I hope this problem is clear. Let's move on to the next slide. Find the length or angle of measure, okay, of these. You got to use the given information and find this, okay. WXYZ is a square, they are telling. I'll do the first one, then I'll give you chance for second and third. WXYZ is a square. If in case of square, all the sides and all the angles are equal. Okay, and they have given Wx as 1 minus 10x. So this is Wx, which is 1 minus 10x, and they have given yz as 14 plus 3x, and they are asking us the value of xy. So first let's get the value of x, equate these two. 1 minus 10x equals 14 plus 3x. Okay, add 10x and subtract 14. 10x plus 3x is 13x, and negative 14 plus 1 is negative 13. Dividing by 13, I get x equals negative 1. Okay, we can substitute in any of them. Okay, let's substitute here. Negative 1 times 10 is 10, 10 plus 1 is 11. So Wx is 11. If Wx is 11, each of this side is 11. So this is also 11 and this is also 11. So I can say xy equals 11. Okay, all of you try these two problems. The last, try this one first. I'll give you a chance to work on this. Give me answer for this. I'll give you exactly 30 to 40 seconds. Okay, let's go over this as well. WXYZ is a rhombus, and x and z are the opposite sides. You can see that the way it is labeled, opposite angles. Sorry, opposite angles are congruent in case of rhombus or any parallelogram. So you can just equate this. (24 times 10 minus x will be equal to 6 times of x plus 15. 24 times 10 is 240, minus 24x equals 6x, and 15 times 6, which is 90, and put all the x terms together, add 24, subtract 90 on both sides to get 30x, oh my bad, here 24x. So here 30x will be equal to 240 minus 90, which is nothing but 150. Then divide by 30 on both sides to get x as 5. So once you get x as 5, you can substitute in z. Let me find angle z. So if I substitute here, x equals 5, 15 plus 5 is 20, 20 times 6 is 120. Okay, observe here, y and z are adjacent. Adjacent angles will add up to 180. In case of parallelogram, we had seen that the adjacent angles add up to 180. If this is 120 degrees, then angle y is 180 minus 120, which gives us 60 degrees. Okay, so the final answer for this is, measure of angle y is 60 degrees. So I hope this is clear. To the last one. Okay, work on this one. I'll give you another 30 seconds, then we will go over solution. So we had here sum of these three sides, xz plus xy plus yz. Xz plus xy plus yz is the perimeter. So sum of these two will give you 24. So 30 minus x If you observe 13 minus x plus 5x minus 1 equals 24, because the perimeter is sum of all the sides. So once I can simplify this, put all the constants and variable together. The 13 minus 1 is 12 and negative x plus 5x is 4x equals 24. Okay, further I can just subtract 12 from both sides to get 4x equals 12, and dividing by 4 on both sides I get x equals 3. Once I get the value of x, I can find xz. xz equals 13 minus x, which is nothing but 13 minus 3. That gives us 10. So if I get xz as 10, I have xz which is 10. xz and wy will be congruent, because in case of rectangle we studied that the diagonals are congruent. Wy equals 10. Okay, I think you can utilize the rest of the class time to work asynchronously on these problems. This will be a homework. I will give you a link where you have to turn in this particular homework. Okay, you have rest of the class time to work asynchronously.